Previously, descriptive measures such as the mean, the variance, and standard deviation were defined. These measures can be expressed in terms of probabilities of random variables. Assume a mean or an average is provided for all the final grades in class. The mean represents the expected value, denoted as E parenthesis x, or the expected value of x. Alternatively, a mean can be classified as the sum of the weighted probabilities. So we take all of the probabilities and use them as weights to each one of the values that we have. If only a set of probabilities are given for some information, we can actually still compute a mean, and this expected value given by the symbol E of x in boldface font. Let's look at discrete probability expected value. The table on the right shows 5 possible values and the count for each value. So we have values of 1 through 5, the total counts, and we can compute the probability for each by taking the total count of each value and dividing by the total number of counts we have, which is 60. So the probability of value 1 occurring is 0.167 or 16.7%. The probability of a 2 occurring is 0.20 or 20%, and so forth. So to calculate the expected value or mean, we use the following formula. Mu is equal to the expected value of x, which equals the sum of each value, denoted here by xi, multiplied by its associated probability. By doing this and then adding them together, we would end up with 1 times 0.167 plus 2 times 0.200 plus 3 times 0.133 plus 4 times 0.233 plus 5 times 0.267. And we would get 3.233. Therefore, the expected value of x is 3.233. If you look at the probabilities on the right here, you can kind of see, based on the total counts, if you were to imagine drawing this out a little bit, that I have about 50% of the items to the left of 3, 50% a little bit to the right of 3, but the numbers to the right of 3 are a little bit higher because they are 14 and 16, whereas the ones to the left are at 10 and 12. So my average would kind of be almost intuitively a little bit higher than 3, and that's what this shows. We can also compute a variance very easily by using a formula below. Since we have our expected value, which is needed in order for us to do the variance, because remember, the variance is related to the distance between each value and its mean. Once we have that mean, our variance can be computed with those same probability measures. We calculate the difference between each value and we subtract it from the mean or the expected value. So that's the xi minus e of x here. We square it and then multiply it by the probability. Once we're done with that, we just add them all together. Here we show this in the table. For each of the values, we're going to take that value and subtract the expected value, which in this case is 1 minus 3.233, which equals negative 2.233. We will square it and we will get 4.986. We will multiply it by its probability, which is 0.167, and get 0.833. We do the same thing for value 2, which is 2 minus 3.233, which equals negative 1.233. We square that and we get 1.520. We will multiply that by its probability, which is 0.20, and we will get 0.304. And we do the same for value of 3, giving us a value of 0.007, the value of 4 giving us 0.137, and the value of 5 giving us 0.834. We add them all together and we get 2.115. Therefore, the variance for this discrete probability distribution is 2.115. We can also compute the standard deviation of this, which is simply taking the square root of the variance to give us 1.4543.